We're here with Shrisha, one of DevEd's resident hardware design experts. Hey, Shrisha, so why is developing a power supply so complex?
Hi, Brandon. Designing a power supply can be very complex as there are many steps involved. So, some of the steps is like choosing the vendor to get the power supply IC from, and designing the circuit and PCB layout. And the most complex problem of it all is designing your flyback transformer. So that would be the most complex of the above, like in the power supply design process.
So, in terms of designing the transformer, are there any tools or anything available to simplify that process, especially if you're not an advanced power guy?
So there are many tools available for transformer design. One which I found is very easy, which can simplify your entire design process. That is the Power Integration PI Expert. So Power Integration is a silicon provider. They design power supply ICs basically. So they have their own web tool. So you don't even need to install it. So you can use that to design your power supply. So this is a Power Integration. So this is the company that produces something like produces lots of silicons. But specifically why I'm choosing them is basically they have something called as a designer, start designing and those kind of thing. So if you see here, they have some web tool called a PI Expert. Okay. So this here you can just put your requirement at the start. Basically you have application. So what kind of application you want to design. So if I go with something like you can go with chargers or adapters or industrials as well. So or computers and servers depends. So I will go with this. IoT and smart home is also possible. So I will go with industrial, and you have your power ranges. You can select the power ranges as well here. So I will go with the 10 watt because that's what the kind of power supply we are designing. So universal is basically you have multiple different options as well. So low voltage DC would be something like normal buck boost converters, you have it, right? Like small 30 volts converters and all those kind of things. So we are designing for 230 volts, so we'll go with the universal. And this is what I wanted to show. So you have multiple different topologies, like to switch forward, flyback. This is also flyback, but very advanced kind of, some of them are very advanced. So we don't need that. Let's just concentrate on like the flyback. You have multiple other options as well, like LLC, half bridge. These things are like they are like similar to flyback, but much more advanced. And let me just select flyback and isolated. So this is what I was mentioning, like isolation on non-isolation. So this is very important because what would happen is like if there is no isolation and you have some if you are planning to do some series parallel operation, that could be one of the, it can create issues there. Or it could also like if you have directly connected your AC line to one of the things like 5 volt or ground, that could be interfering with your Wi-Fi or Bluetooth. Those kind of situations also could come up because it's just you have your AC signal, right? Those will create a lot of noise on this when there is no isolation. So you have, this is what it would look like most of the time. So you have your, basically if you consider one of these points, there would be much more have your rectification circuits here. But if you consider this live and neutral, you have your one of the line directly connected to your output, even the other line is directly connected. So it's not exactly like completely isolated from the supply. So this entire circuit is completely isolated from this entire circuit. Here your feedback would be there, but yeah, the feedback is also completely isolated. It would be something like optocouplers. So you have otherwise it would be something like a transformer winding itself. So normally whatever adapters, power chargers, everything would be something implementation of this itself, but bit more complex. Like they would handle protections, you would have protections, and in case of if it's a USB-C kind of a situation, you would have some kind of power conversion also would be there. So you have your feedback, right? So the feedback would be controlled to a level like, okay, I need 5 volts, I need 20 volts, so that it would support the USB-C standard. There is many ways to do this. Let me just do the start designing. So I will just press that, and I will just say start designing. So it is here we come, and here I will just select the application, which is for me the application is 5 volt 2 amps power supply. So I will just choose the application. So there are many applications, you can just go with industrial. And the power output range, so the range is 5 into 2 amps is 10 watts, so I will choose 5 to 10 watts. And input type is AC, so universal, I'll go with universal. And type number of outputs, I only have one output, 5 volt 2 amps, so I'll just select that. And isolation is required or not required, isolation is required for our case, so I'll press yes. And output type, so we want constant voltage, so 5 volt is the constant voltage, so we require that, so I will select constant voltage. And the topology, for topology I will go with the flyback, since that is a very popular, I'll go with that. And then it will give me a lot of options here, so you can test each of this option for your application, or which suits you better. I will go with the tiny switch for flyback, so I will select this and I will press pi expert. So this will load a new window. So we have here full bridge rectifier, that is rectifying our AC input, and that is stored in our capacitor. And then we have our tiny switch, which is the IC responsible for our application flyback. It is our flyback uh, IC PWM controller. So that is responsible for generating the PWM power, which will be fed to the flyback transformer. This is the primary side and this is the secondary side. On the secondary side, you have uh, a diode which rectifies this AC which is coming here, and that is again fed to a capacitor where it is filtered, and you will have certain voltage here. So, and that voltage will be fed to a optocoupler. So this optocoupler is again, one side of it is connected to the secondary of the transformer, secondary side, and another is on the primary side. The primary side is your output, so this output is again fed to the tiny switch. This tiny switch, this is the feedback for the tiny switch. So if you have some, okay, so in application when the load changes, you have a its voltage change here as well, it will drop or it will spike up. So at that time you need a feedback to correct the power on the output. So that is why you have this optocoupler here. So this forms as a feedback circuit. So this is a simplified circuit diagram. So we can just select next here. And again, so if we go here, AC defaults, so it is universal, so from 85 volts to 265. So this will support both Indian and European, you know, European and American version as well, like the power. So line frequency is 50 hertz, for American that would be 60. I think this will support it. Let's go next. So here we need to specify the power, so voltage and current. So I will add it. So we'll add 5 volts and 2 amps. So it will calculate the power, which the maximum power is 10 watts. I'll press OK. And yeah, it has come up. So I'll press next. So here we can actually give our design name. So if you have logged in, you can actually log in, it's free, or you can actually design as a guest as well. So this is assigning the name to your design. So you can just now look at this, and then you can select finish. When you press finish, it will reload the window. And now you have a pop-up window here. This is for the transformer, it is asking for transformer turns. And as you can see, it is right now the design is failed, it is saying, as it has not done the optimization. So you can just select the default values, you can just select OK. And now if you see in the down, you have a progress bar that is optimizing your design. And now it has generated the bomb. So I'll just press OK.
Okay, I was gonna, I was gonna wait and say but your design failed. But when it was optimizing it, it was actually literally taking care of all of those, whatever those things, those design flaws or whatever that needed to be addressed. So it essentially scanned your inputs and then updated the components that it would recommended for your design, right?
Yeah, yeah. So you have your multiple resistor values here and the capacitor values and the inductor values. So it was optimizing these values for our application. So this particular switch supports multiple power ranges. So you can set it as a 12 volt and 2 amps, 12 volt, 5 amps. Probably it's possible. So it is basically depends on your feedback resistors and your output component values. So it was basically optimizing those values. As you can see, this is a schematic it has come up with. So you have here the basically four diodes which form the full bridge rectifier, and you have your capacitor. So this is actually storing this voltage what is generated here. If you think about this, this is similar to the simplified diagram which it has showed before. So you have your flyback. No, this is just the filter. So EMI filter this would be, and again you have a capacitor here to store the filtered DC value. So you will have a DC value here, high voltage DC value. It would be in ranges of something like, for at least the Indian voltage, it would be like if you have AC here, for example 230 volts, it would be something like 315 something volts here. So and again you have your PWM controller. So this has an integrated MOSFET, so you don't need to add a MOSFET extra. So this is controlling your flyback transformer. This is a very simple flyback transformer. Uh, so you have one turn here and one another turn on the secondary. So you have some of the snubber circuits, these kind of filtering circuits, and this is output where the AC signal from the transformer is rectified, and that is actually like stored in the capacitor. So if you have some voltage changes or there is a high current demand, then you have this optocoupler. This is the same part. So these two are the same part, and optocoupler provides a complete isolation between the primary and secondary. So yeah, so by this they are setting the voltage on the output. And if you see here, it has given the design details as well. It has calculated multiple things, for example power supply input. So it has calculated all these values. If you open up this IC datasheet, you will find all these values as well, and formulas to calculate for your application as well. But this tool has actually automated the entire thing, and it has calculated everything for us for input. And you have your transformer construction parameters. So all of these are like the kind of core material, core type, core material, and you have the turns on primary and secondary and things like that. And if you see the board layout, so it has even given you the board layout. So this is the IC for us. So this thing, this image, you can directly provide this to your PCB guy, and he will make the similar PCB. So this is very optimized for this design. So this PCB layout. And if you see the BOM, it has calculated the BOM correctly, and it has provided you the table and even the part number and manufacturer number as well. So the company which manufactures it, everything is provided. And the most important for these kind of design, the most important thing is the transformer construction. So this will take a transformer guy but the transformer guys, yeah, so they need a lot of experience, multiple years of experience, but this would very simplify this process. So it has given you this page. So this would look like a data sheet for your transformer or the flyback transformer. Yes, so this you can directly give it to your transformer manufacturer, and they will produce a transformer as per this requirement. So it has given you the designers and everything. So you have even more things explained here. For example, this is the, if you want to see all the things, um, input section, if you are seeing the part number, it is as, yeah, rectifier, what kind of diodes it is using, diode set, and the fuse, everything. Everything is broken down into things which can be understood. Yeah.
What would the next thing be beyond this? I think, I mean, once you've designed a power supply, I mean, is there another step that we should go?
This is basically a primary step. So what would happen next would be you take this design and you verify this with a, like a guy, power design guy. So he should verify this entire process. He should have multiple years of experience to verify it as well. So otherwise, okay, so you have got to a point now. Now you can go to the verification. So what would happen otherwise? You would actually give the design construction entire process to the power guy. Right now, you can just have him verify this design and the transformer. So your entire one of the step is cut out, but still, so the verification is still pending because we don't know how good this has designed and is it applicable or not. So he should go through the data sheet and he should verify this entire process. That is the first step, and then you would basically produce a prototype and you will get the sample of the sample transformers from that data sheet, and then you would basically do power on sequence. Yeah, so you would assemble the entire thing. You will check the impedance, resistance, if there is a short or not on the PCB, and then you would power it on with the very low voltage. So it starts with 85, right? You would start with something around that voltage.
All right, that's great. So, I mean, this is what we're all about, is shortening the time to market and making things easier for developers. So, if developers have questions, Trisha, about verifying their circuits or making sure that everything is designed correctly, maybe not all the way through verifying their entire design, but all the way up to that, where can they go?
So they can visit our DevHead server. So there are many people who can support you there on multiple different things.
He's at Trisha at 97. I'm at TechieLou, and you can find both of us and all of our embedded and IoT engineering experts in the DevEds Discord server, which is linked to on screen and in the description below. We'll see you in the server.